So this will be lecture on that is introduction to C and C++. I do these slides together with my best student, Łukasz Pluszyński. Yeah, so you can always contact me by email. Yeah, and let me move with the program. So basically today I will describe what is computation and computer program. And then I will mention about compiler and interpreter. Then there will be some remarks on flow of control, and some examples of simple programs. In particular, I will show how to implement array and string and how to have input and output operations. So first thing which comes to our mind is definition of a computation when we think about programming. So in mathematics, computation is operation on real value variables. And then we have a mathematical system that is disattached from physical reality. So we have like 2 plus 2 is 4, right? Sometimes if system is very noisy, like in analog computer, 2 can be 4.1, but still is pretty much more or less 4. So in real computers, in real physical systems, computation is physical process that is about evolution of physical system from some initial conditions, initial boundary conditions into final conditions. And then we need to be able to set read input, and we need to be able to read output of given physical states. And the reading of output is about making a measurement. I make some reference to general framework on a computation, which is both refers to classical computation and to quantum computation. And then of course it's the most current computers are made from digital and electronics. But still, there are very remarkable examples of mechanical computers. So I recommend you to study some cases for those who are more interested in the subject. Okay, and computer program is a series of instructions. This is also called code, given to the computer to perform some task, which could be anything from summing the numbers, as from 1 to 10, up to modeling of climate. When the computer follows the instructions given in the program, we say that the computer is running the program. There are many different ways of writing those instructions of a computer. And basically, we are speaking about different programming languages. Right now, let's say special programming languages are developed, especially in the field of quantum computation. That's one of my specialty. But of course, we will be talking about C++. Nevertheless, just to let you know that we are able to create programming language from scratch. So, and then we can have the chain of commands that we should refer to very good cases as C++ or Python, for example. All right, and then just to see the realism of the operations. So everything what is done by computer is done. It can be referred to logical gates. Operation on with use of logical gates when you have the OR and AND operation, and you can also have NOR and NAND operation. So of course, what happens is that what really happens is that the computer, we are able to write a computer program in high-level programming language like C++, Python, let's say Pascal, right, Fortran, and Algol, and so on, and then having the computer program in high level language. The compiler is run, and then the code is translated into machine code that basically sooner or later promotes certain connections between that implement a chain of logical gates. So it's a kind of long process, and you need to know that computation is always so like Turing machine. Computation is referring to the Turing machine concept, and the computation always is divided into sub-processes, physical processes, one occurring after another. So computation is done in a real physical system. Nevertheless, due to high level of technology development and due to high level of reliability, the computation can be very much repetitive. So in that sense, we can try to forget about physical layer and think only in mathematical way. So there's a bunch of gates, logical gates. I'm sure you happen to know it from previous courses, or at least you will have on the coming courses. I simply try to see your kind of try to broaden your view. So basically we have AND gate, right? So we have two inputs and one output, and so we have two logical variables on the input, one on the output. So of course, if two inputs are true, then output is true. Otherwise, output is false, right? Then we have an OR gate, right? So basically, we have the second case is OR gate. So we have two inputs, one output. So simply saying, we have this case of if at least one input is non-false. So if at least one input is true, then output is true. And if two inputs are false, then output is false. Yeah, that's OR. And then there's the same version of like AND and OR, but with negation. So there is special dot over here. So you have NAND and NOR. So the only difference is that the operation coming from AND output is later negated, so change into opposite. Then we have a XOR gate. This is symmetric difference between inputs, and so on, XNOR gate and NOT gate. So you can follow those gates in literature. It's quite straightforward. You can also try to implement such gates with in a computer program. All right. So then coming to the concept of a computer program, at first we need to think about algorithm that is a kind of more general concept, the concept of a program. So particular program is just implementation of one algorithm, but of course you can program in different languages. So there is a concept of flowchart. So basically, what you have is you have certain symbols, as you can see. So if you go to the, let's say, import, you are subjected into certain algorithm of checking of boarding the plane. So you have to wait in the queue. Your passport is checked. If all documents are okay, you go this way. If something is wrong, you go, or there's some extra checking, you go another way. So it's fully deterministic process. So this is and this fully deterministic process can be used without flowcharts concept. There's wide literature on that. I will give you example of that in more detail. So basically, you can you can get first 20 numbers, for example. You can start to think how to write it by means of this. Sorry, by means of this. So how are you going to do it? So at first you start it, right? Then you have to initialize one variable, and then simply, and then you have to increment by one. And then, for example, computer program, you print it. So this is such shape stands for input output, and there's a checking if it's smaller than 20 or not. If it's smaller, then you come back to increment. If it's above 20, the process is going to stop. So basically, you can write down you can write down this. So this rectangulars are about mathematical operations, like the elementary operations. It somehow can be done on a processor, on a coprocessor, and this is how you call it, this shape. This shape is about input output. So this is about printing, and this is about if checking the condition, logical condition, and this is obviously about the loop. So I'm sure that the kind of loop concept, at least you have heard of that. So of course, maybe it's a good case to write later first computer program that solves the quadratic equation using this flowchart concept at first, and then we will implement such computer program in C++. So probably this will be our first tasks during a lab. But as you know, right now I try to give some extra, some introduction to theory. All right. Then there is a history of C. So it's quite important to recognize that it was developed by AT&T Bell Labs in 1972. So it's a pretty old language. It was designed and written by Dennis Rishi, and then this language started to replace other languages like Algol. So then there was a concept of Ansi C Standard emerged in early 80s. And there's a book about programming in C. I will later cite literature. So this standard of Ansi C was developed. And then, of course, this is C was usually developed for programming Unix operating systems. As you know, the Microsoft made a career in 80s as a company, but before the Windows was popularized, simply saying computers were used by professional institutes, and people devoted to do a computation. Yeah, so for example, it's important to mention that a lot of code written in CERN is written in a Fortran, and then partly in C, but I mean, the Python, for example, is not that frequent. So CERN is not so frequent user of Python as you might think. So simply because the computer language at first computers were devoted for computations of trajectory of rockets and so on, for real experiments. And later it was new categories has emerged as writing computer games and so on. Yeah, so we have Ansi C compilers, and then so it's simply saying that one of the reasons to use C is the speed, and then the C was upgraded to C++. It's also important to say that like Windows is switched in C. So C is really second used programming language. Of course, there's a big fashion for Python, but simply saying so far, I mean, C has very long tradition in computer science. All right. So, and then we are going to use integrated development environments. So there's three-letter abbreviation, as you can see, EDE, and then the process of editing, compiling, running, and debugging program is often managed by a single integrated application known as Integrated Development Environment, or EDE for short. And EDE is a Windows-based program that allows us to easily manage large software programs, edit files in Windows, and compile, run, and debug programs. And on a Mac, operating OS X, CodeWarrior, and Xcode are two IDEs that are used by many programmers under Windows. Microsoft Visual Studio is a good example of popular IDE. And Calyx is a popular IDE for developing applications under Linux. And most IDEs are supporting program development, are supporting program development, so like several programming languages. So like C, C Sharp, C++, and so on. So you see this, that's the computer science is extremely well developed discipline. So let us say we will try to give maximal, just have a short insight into C and C++. And so probably it's recommendable that we choose our environment. I will make some kind of discussion with you guys, which example you want to choose. So I will request you to write reports, and in these reports, which supposed to be written and finally in PDF, like so I can use Acrobat Reader to read it. No other format I wish to have, just PDF, because just opening the same document under many environments, it's a little bit mess. So in every report, I will ask you guys to have the code, and then the code program, the description of that, and this code program shall be written in such a way that it can be executed. So in a sense that you report about the working program. All right. So that's okay. So we need to discuss after a while about proper choice of integrated development environments. Maybe I'll also give you some level of freedom to choose it. We will see later. Okay, and then we are coming to structure of C language program. And there is a command line, preprocessor directive, global variable declaration, and there's a main function, local variables, statements, and user-defined function. And there's also command line. And so you have to see special way of commenting. As you can see, these dots are commented in a way, and so you need to start commenting process and end commenting process. So simply saying, the compiler omits everything what is in between. That's quite crucial. You can basically view C++ as upgraded version of C, so in a sense. So please have such view. Also, if you happen to have special requests or special types of problems you want to do during classes, I'm very much open-minded person, so please let me know by email about your preferences, your interests, your choices. So I try to incorporate your idea into the program course, so we can both benefit from something new, right? All right, so yeah, I don't know if some guys have practice in, because I am a little bit probably older than you in most cases. So let's say, so at first I grew up with Pascal language, programming language, and there was a procedure and function. There was this difference, and here we have only kind of function like, so that's kind of small difference. And of course, C is more abstract language, and its speciality is also about that operators can change the domain of application. So yeah, so this language is quite flexible. We will come to that issue a little bit later. All right, and then we have low-level languages. So basically, we have like assembler language. So okay, so low-level languages are machine-level and assembler-level languages. In machine-level language, computer only understands digital numbers in the form of 0 and 1. This is what I have shown at the very beginning. So instruction given to the computer is in the form of binary digit, which is difficult to implement instruction, and this is generally difficult to implement instruction in binary code. So when you know, there was ENIAC computer, and in 50s, when there was a concept of, there are two concepts of a computer. Was analog computer, and that uses analog electronics. So for example, it integrates and differentiates using operational amplifier, for example. So it can incorporate equations. And there was the concept of digital computer. And simply saying, so those two computers have been used, and those two computers have been used, and but it seems to turn out that digital computer concept was somehow better. So people abandoned the concept of analog computer. And in the very beginning, everything was encoded in low-level language. But later, the high-level languages was developed. So instruction given to computer is in the form of binary digit, which is difficult to implement instruction. And this is difficult to implement such instruction in a code. And such program that is written in low-level language is not portable. And of course, it has to change its configuration depending on a computer. The assembly language is so basically it uses the processor registers. You have processor registers, and then you have to make all the operations on the registers. So imagine that you solve the quadratic equation trying to set certain registers in a certain state. So you can have some reference to assembly language. You can write some viruses on a computer viruses. So there's a bunch of operations like add, sum, move. And you have also ability to embed part of code in assembly language in the framework of C or C++, as well as in a Pascal programming language, for example. Yeah, so basically we don't touch low-level languages because of level of difficulty, but let's say disadvantage of using high-level language is that when it translates, there's some level of translation into final machine code level. So simply saying, by this translation, what happens is that the code is not so quick anymore. So there's a not the most effective way of doing so. So especially this is known to people from CERN. You know, the CERN, the particle collider that is in Geneva, and also between French border and Switzerland. It's on both countries. Sometimes there is a need to make a computer program that has very quick execution time, for example, in the range of milliseconds. And doing so, you cannot use high-level programming language because your translation process is not ideal. So you have to do step by step using low-level programming language. That just to let you know that such possibility does exist. Of course, if you want to write a viruses, maybe also a good idea to use low-level languages. Yeah, so I just to mention that such low-level languages exist. It's assembler. It's a subject of another course or another field. It's for those more interested in the subject people, then please refer to that. And of course, the better is a processor. The new generation, the more of computer, the new generation of processors has more and more registers, so it's more and more homework how to learn on assemblers. Becomes this knowledge becomes wider and wider. All right. Then we have the high-level language. So these languages are machine dependent. It means they are portable. Yeah, you have this, like the case I already mentioned. Pascal, COBOL, Fortran, etc. So Fortran was very much devoted to only computation. CERN has probably the most codes written in CERN, and there are millions lines of codes developed over the last 50 years, mostly written in Fortran. Nodes are a little bit under translation into C, C++, and so on, and probably also Python. Yeah. So basically what we have is high-level languages are understood by the machine. And then, of course, everything, the whole translation to this gates connection, as it was at the beginning, is done automatically. And there's a translator software which is used to translate high-level language as well as low-level language into machine-level language. And then we have basically compiler, interpreter, and assembler. I would like to mention to you that right now I'm kind of personally interested in development of quantum programming languages and quantum compilers, since I do have my own company associated with quantum technologies. So just to let you know. All right. So this field of quantum compilers is right now very actively developing. All right. So this compiler interpreter in greater detail. So compiler and interpreter are used to convert the high-level language into machine-level language. The program written in high-level language is known as source program, and the corresponding machine-level language program is called as object program. Both compiler and interpreter perform the same task, but their working is different. Compiler reads the program at the time and search for the error and list them. If the program is error-free, it's converted into object program. When program size is larger than the whereas interpreter read only line of the source code and convert it to object code. Yeah, if it check error statement by statement and hence of taking more time. So yeah, so you have basically the role of compiler and interpreter. Of course, if you want to be more specific, well, you can see the object always generated when you compile the C or C++ code. There is also, I would say, added features in C and C++. So we can have procedures in so like procedures based programming. There's a paradigm for a programming. So a paradigm focus on a procedure calls like subroutines consisting of repetitive steps to be performed, which can be triggered at any point in the program operation by other procedures or by themselves. Yeah, so like procedure for adding numbers. So it's like a kind of very specific algorithm. You can call it a procedure, taking given number to certain power. It's a procedure. So obviously you have in Pascal, for example, you have a explicitly procedure declaration end of procedure, and function declaration end of function. In C++ or in C, the function that is giving so basically procedure can be also seen as a sub-program. And when it gives you, when the return is void, so it's like empty return, then the given function in C can be called as a procedure as well. I will come back to that example later. Then we have object-oriented programming. So in object-oriented programming, basically, the idea is that data and procedure are interlinked in a way. So that's you will see so how these things can be done, and this is object-oriented programming. Yeah, we will have the possibility for creating objects later during this classes, right? Yeah, it's a distinction between, let's say, data and hardware is artificial distinction. That's quite important to mention. It's a quite artificial distinction. So yeah. Can you see still my screen? Hello?
Yes.
Yeah, okay. It's because I went out of the full screen, I guess. Yeah. So I'll come back to that later. So basically, if you look on biological living cells or a human being, we can recognize ourselves as a kind of biological computer as well. And then it's not fully obvious what part of us is about data and what part of us is about hardware. So those categories are very much mixed or interlinked. So yeah, but of course, so that's the reason why we arrive into objects. Then it's simply better to structure various types of algorithms. So there are certain type of data and certain type of mathematical operations on those data, and so they call, you call it object. Yeah, we will have the occasion to go deeper into that. Yeah. So as about object-oriented languages, certain concepts can be presented. So basically, yeah, we have a class definition of data format and procedures for a given class of objects. It contains methods and variables belonging to all its members. There is object, a specific instance of a given class. It can contain its own variables independent of other instances of the class. Then we have a class variables shared by all class members. Then we have instant variables belonging to the given instance. Then we have inheritance, the process of inheriting by class the methods and class variables of another class called a parent. Yeah, so inheritance, they have a class of a car, category of object known as car, and subcategory of truck as example of. So you can inherit certain features from car and incorporate it into subcategory of truck, yeah, or transporting vehicle with transporting big cargo, something like that, right? Yeah, so this is about inheritance. There is encapsulation. So it's about hiding class data and methods from access from outside. Yeah, so if you want to create the environment known as Mathematica programming language, in a sense, the Wolfram, who is the author of Mathematica, encapsulated all procedures. So you don't know how things are executed, but you only get input-output. So encapsulation concept was used, right? Then there is a polymorphism, a mechanism related to the class inheritance hierarchy, where the result of a method call depends on the type of the calling object, right? Abstraction. So this is about hiding the class internal mechanism from other classes. In principle, reading and modification of class instance data should be performed throughout design functions, getters and setters respectively. And there is multi-inheritance, inheriting from multiple classes simultaneously. We will come to this concept, to those details later. Yeah, and then it's time to become more kind of concrete. So I'm going to introduce some operators in C and C++. So then there's operator greater, then greater than. So you have it on the left. It's quite intuitive. How it's written, nevertheless, formally I need to mention it. Then there's next operator greater than or equal to. You have another operator like that. Then there is less than operator. Of course, it's also quite intuitive. Less than or equal to is given here. Then we have equal to. So you have it like that. And so double, in a sense, double equal, you can say. And not equal, so there is negation of equals. It's written like here. Right. So just to know it. Of course, during writing programs, I would say you'll practice this. it may be a kind of new to you, but you can try to write first programs on the sheet of paper, and then because simple programs are quite easy, can be done quite easily, and then you can code them and so on. So of course it's up to you how you are going to approach it, but somehow writing down with your own hand is a good way to start with, I would say. Okay, so there are operators in C++, and then of course there are tons of operators. I would just mention some of them. There is like operator AND, logical AND. So you have, it's given here. There is logical OR. So you simply need to have one logical variable on the left and right to have such operation. And the operators true and false, of course. So this is logical. So of course you have A and B table of possible values. So you have AND output given here. Yeah. Maybe at the very end of this lecture, I will mention about literature and what is a good link for such lecture materials as it is given here. Okay. Then we have certain loops in programming language. So for example, there's a while loop. So it always repeats itself. It can repeat infinite number of time, for infinite number of steps, for infinite long time, if certain logical condition is fulfilled. And there is a statement 1, 2, and so on that is being executed. So certain, procedures could be executed during that loop. So we have a while repeat loop. Then we also have for loop. For loop is different than while. I will give you some examples of that later. All right. Yeah, so for loop has, so you have a special type of brackets over here always. Just look on that. So there are special types of brackets. And there's logical condition. So the output of this bracket has a logical value. So if while and this logical value, if this logical value is 1, is true in a way, this is executed. Otherwise, this while is stopped. So program jumps to after in that place after this while. So for loop is different because this loop while can be executed infinite number of time, and not always we want to be like that. So this loop for has some final number of steps of execution. After, if you exceed this number of steps, it's simply finished. So the time of execution of for loop is deterministic in a way, while time of execution of while or repeat loop is not known well. It's undetermined in general. So then we have as about syntax for loop. We have place for initialization of variables, setting their initial values before execution of this loop. And there is a condition that is always checked. So if condition is satisfied, everything is executed. So it's like one time it's executed, and then the condition is checked if it's fulfilled, and this is executed another time and another time and another time. So this like incrementing value of numbers, so increasing number of value from 1 to 20, 1 plus 1, 2 plus 1, 3, and so on. So if it's still smaller than 20, it's being executed. And there's incrementation condition also given here. So you have such syntax as specified here. All right. Yeah, so then, yeah, I will come back into more details. I don't want to overrun with, to be over formal in a sense. Obviously, I can be more formal, but I don't think it's a very practical approach. So if somebody wants to be a formal, always, or you can always express your formality or your abstract way of thinking in your reports, for example, right? So I basically request you to do reports. So like today, I also request you to do a report for next week, basing on this lecture, which is today. Yeah. And just example of simple program. This is the simplest program that writes down the colored text on the screen. So what parts does it has? It has main function, which name is main. This function takes no arguments, so this rounded bracket is empty inside. There's nothing inside, and it's always important that the function returns some value. So here, this value which is returned is 0. So it's integer. 0 is integer number. 0 is integer number, right? And so it's declared over here. That the function is sorry. The function is returning 0 number, the integer number. So you have to write it here 0 or other value. But this value must be integer if you state such function like that. And then there are streams, input-output streams are declared with such declaration of as given here. And then C output. So this is output of standard C output. So it's so this is by default such text is like thrown on the screen. So that's so you have a kind of string value. So variable that has a string that has string values. Maybe I should say something more about variables. I will do this in meantime. Yeah. So this code only if you write such code, you compile it, and then you run it. It's run step by step. Then so the output is only one text of line on the screen. All right. We need to exercise it. I'm just now mentioning, right? Yeah, and then I should say something about data structure. So I will just to mention you. So there are various data that you can use. You can also create a new type of data representation. So there is some preliminary data representation already given to you. It's like int stands for integer numbers. So this is -1, 0, 1, 2, so on. Then you can have a double type of data. So this is about real value numbers. So -1.25 is a double type, right? It's not int type. Yeah. So then of course, if you use some extra libraries, you can also represent complex numbers. You can have addition on the complex numbers, or you can write your own. Actually, you can also write your own, I would say, class that expresses operations with complex numbers, or you can use already existing one. Yeah. Yeah, so you also have this type of data known like ASCII code. If you type the letters of alphabet Roman alphabet, like the European Latin alphabet, right? So then you have to use special representation for this, and this name of such data is Char. And I will mention about this. So it's not value, mathematically value number. Of course, it's also translated to certain value in certain representation, but a special category of data that comes from typing on the keyboard, right? Like text data. All right, so, and then you can have a simple variable, like simple number, or you can have an array of numbers. And of course, you know, right now every personal computer was 20 years ago was a supercomputer. So we have quite big memory, and then so definitely more than one number we can store. So we can store arrays, or one-dimensional arrays, or many-dimensional arrays. Yeah, so what is array? An array is a fixed number of elements of the same type stored sequentially in memory. By the way, you have different way of array representation, of course, in higher level programming language and low level programming language. You can use stack in low programming language, just to let you know. So yeah, so array is a fixed number of elements of the same time stored sequentially in memory, and therefore an integer array holds some number of integers. A character array holds some number of characters, and so on. So the size of the arrays refers to its dimension, and to declare an array in C++, we write the following kind of. So we have a type of array, like int char type of array. So this is this type, and then there is array name, so name of variable, and there's a bracket. In the bracket is dimension, and so how long array, how many elements should it have? So it has 4 elements, so it starts from 0 index. So this is this tells you to the computer how much memory it should devote to such variable. And yeah, okay. Then sometimes you can declare existence of variable, but with empty bracket. I will mention on that issue later. Okay, and how to deal some examples of arrays of data. All right, so this is declaration. So you see, it's quite, just remember, not every programming language has this feature. So that's the declaration. This line is about declaration of array that has 4 elements. 4 elements. But indices start from 0 and are 1 below this value. So in a sense, this is like n plus 1, something like that, and you go until n. So it starts from 1, 2, 3, 4 elements of array, and then you set values explicitly, like by hand. Of course, you are not going to do such things explicitly if you have 1 billion of elements, but simply saying for a small number of elements, you can do it by hand. So there are certain integer values that are set, as you can see. And then another way is to initialize so that's the same type of effect as you have here. You can implement with usage of such type of bracket. Then you simply can declare like that. So you see, this is more compact way because this is 1 line. Alternatively, you can So sometimes it's more convenient to leave out the size of the array and let the compiler determine the array size for us based on how many elements we give it to. So we have integer space array, and there's empty bracket, see? But simply you explicitly give it in such form. So I encourage you to make some notes from today's lecture, maybe a little bit. You see, making notes by hand, writing on the paper or by some, in electronic way, but making notes is very important. So I always used to fight with concept of flash memory. So many students, those times are people are very much distracted about the, we use mobiles, we connect to internet very often. Yeah, so the concept is to be able to concentrate on one element for a very long time. So, for example, the tradition of 5 hours of seminars were developed during Cold War time. So people concentrated on one issue for 5 hours. So, for example, if you read a monography book, you turn off the mobile, everything else, you concentrate on one thing for 5 hours. So I encourage you to make a note, because many people have such impression that just reading 5 minutes, Wikipedia is a very good tool, for sure, but just simply screening the information, you have illusion that you have learned. No, you don't. You have not learned if you're not able to write a computer program on the sheet of paper, just basing on your memory. So that's just to let you know that it's really important to make notes. So I encourage you to write it down step by step. All right. So yeah, let me move on. So this is about arrays. And this is about a program that collects 4 values, integer values, and then shows these 4 values on the screen. So I will describe this program. So basically, input-output stream, you have to declare that you will use input-output stream. And there is a using namespace std. That's, I will later describe this meaning of that kind of command, but that's kind of, those are too compulsory to run the simple code. And then there is a main procedure, int main, with such bracket, and this ends here. And there's a return 0, of course, because it is int here. And then you have declaration of array that is has length has 4 elements. You remember it has 4 elements, but it starts from first index is 0, and then it's incremented up to 3, right? So there's, if you write A4, it will be error, must be maximum index is 3, just to let you know. Then in this line of code, what you write down is you write, this is the output, what will be seen on the screen of your computer. So there's like this, everything what is here in the comma, it's will be text message that is streamed on the screen, see output. So please enter 4 integers. And there is another stream that is end line. Yeah, so it is like two lines or somehow written. One line has name plus and please enter four integers. Next line is empty in a way. And then it's quite important. So I request you to write this kind of program with like 10 pages report for next class, and try to describe this code and try to write down how it's some parts of this code, what's their meaning and so on. Yeah, so and then you have a for loop here. So it's given by two lines. So essentially you can have the same type of bracket here, but sometimes you can omit it. And basically, so if you write like that, for only that part will be associated with this for, but it can have more lines, but then you need to write this brackets. So there's a for loop that starts with that pre-declares existing variable in variable ei set to 0. And then there's a condition that this for loop is executed if I is smaller than 4. And then there's special operator that is increasing I. This is e plus plus. So this is like set a new values of I, then you increment. So this is like I, next I is I plus 1. It's pretty much it. So you can write it like that. This is quite specific operator. So this is a for loop. Probably, maybe it's new for some of you. And then you direct the output. Okay, now you, sorry, wait for input. Cin, you wait for the stream for input. So the input you put on the keyboard will be given to array as elements of array. So because this loop is being executed 4 times, then 4 times you will be asked to write some number, and better write integer values, otherwise there will be error in your code execution. So you have it like that. You have it like that. Then there is the output. The output. So this part of code, let's say those 3 lines, are responsible for collecting 4 numbers. Okay, there's some chat. Yeah, I will end. Yes, and there was a question: what's the meaning of endl? Is end of line. That's already answers, right? So this is for loop. This part of code, those 3 lines are collecting 4 values, and then you want to see those values you have already collected on the screen afterwards, just to confirm that everything is fine as you wish to have it. So what you are doing is you are using C output stream. So you see that this input output stream is responsible for C in and C out. So you have this way, you have to pre-declare like that. And then you have values in array are now. That's a comment line. So this will free you out this. Of course, you can also add this end line, but maybe you don't need to. You can, but you don't need to make extra. So of course, you can have more chains of such things, like later many variables and comments can be given. Yeah. So this line is throwing you the text on the screen values in array are now, and then you have for loop. You see, this for loop is the same as this one, but basically I should use this type of bracket here and here, but otherwise if it's not used, it means that for only touches the first line after. So this again, initial I, so you have predefined variable I, integer value is set to 0. It's being executed if it's smaller than 4, and it's incremented by 1. So this is e plus plus. And then we have C output. So first is empty character, so like space, and then you add number. So in a sense, those numbers are separated by some space. So you are given this subsequently all these numbers starting from 0. So array 0 is given 1, 2, 3, right? So all these 4 elements are given. And at the end of that, you have C output. This is end line here. So this is just empty line. And that's just return 0. It's just the finishing the execution of this main function. I hope this one is somehow understandable, right? And yeah. So you see, then we can go into next possible level. And next possible level is about definition of some new functions or new sub-algorithms or algorithms. So sometimes certain operation can be repeated many times in the main program. So there is a need to write a procedure or function. So procedural function, this distinction is existing in Pascal programming language, but it's not existing in C and C++. So basically, procedural function is the same. So the function sometimes also return can void nothing, can have return nothing. But here, so what's the structure of this program? I will first describe the structure and then try to. So today we learn how to write the programs, and we are going later to implement them in a certain type of programming environment. All right, so again, include input-output stream is used. It's quite obvious because cout is about input-output and cin is about input-output stream. There is standard using namespace std. I will give more details on this particular comment, but right now you simply need to include it. And then you have definition of a function or procedure, and the name of this procedure is sum. This is the name. So this procedure starts here with this bracket and finish here. And then it is known that the result of this procedure is an integer value, int value. So it's return, but you see return the sum. The sum is a name of variable and also name of procedure. And then it's quite remarkable that you have the values and the input of procedure. So you have constant integer array. It's given here. So this is int array, you already know. So this is int space array with unknown number of elements, right? So that's, and there's another information. This is a constant. It's written here. And then it's also information about, so this is, so it has two, let's say, inputs. One is array of unknown length, and second variable actually gives you this length. So this is, you see, integer length is the name of this variable. This gives you, so it's also information that is constant, right? All right, so what's the content of this? What are the steps of this function or procedure? So first you declare, it's for very, very big integers, it's a long, so it's like int, but it is for very big integers, like, you know, very big. So it's I will make some more details afterwards, but let's say just right now, just consider this long as int pretty much. So this is integer value, and this is set to 0 initially, as you can see. And then there's a for loop. So what does it do? So you have this, you already know the structure of for loop. It has int set to 0. So this is some internal index like use inside the for loop that is initially set to 0. You check if it's smaller than length. That was input of this procedure. And then there's a sum. And then there is such chain of commands as given here. So, so what this is about? So sum is a variable that is equal. So you have a very specific way of writing this, plus equal. This is a special type of operator. So it's like you can also write sum is equal to sum plus array. So basically you take all elements of array and you add it. So you have a sum that's initially 0, and you take array of array of index of 0, and you add to sum that was initially 0, and then in the next sequence you do the same. So you take array 1 and you add to sum. So this is what is done by this line. It's maybe a little bit. So you have those two specific operators. Yeah. So you simply, what does this procedure is it does. It sums all elements of array. So it adds a0. So we have array 0 plus array 1, array 2, array 3, array 4. All these numbers are added in a way, right? So this is what is done by this procedure. So this procedure sum is here declared. In this part of code is declared, and it's run over here. So initially you pre-declare the main procedure in a sense. Main is compulsory in C++ program. So what you do is you first pre-declare very specific values of array as are given like here, 1, 2, 3, 4, 5, 6, 7. Right. So after this, so you have 7 array of 7 integer numbers. Yeah, and then next line you give a command to the computer, stream on the screen the name sum, and then put it on the stream on the screen the value of function sum, that is integer value. So in a sense, this is stands for one number. This is this int number, and then it has arguments. And this first argument is this array, and we already declared this array values here. So this array, this information that's 7 elements length, of course, and then put it on the screen end line, or one empty line, and then return 0. But anyway, what happens after execution of this code will be one number. It's number that's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, right? This will be. So it is n times n plus 1, right? Over 2. That's arithmetic sequence, right? You know how to compute it, but you need to test it. Okay, so I hope this kind of what I am saying right now is somehow understandable. At least I need some time to digest it. You know, nothing is for free. If you learn, you also become a little bit tired of something new. So you have to struggle a little bit. You know, it's always like that. Life is a little bit about challenge and passion. This is my concept of teaching. So you need to have some level of challenge and some level of passion, right? Yeah, anyway, let us move on. So you can, now I want to be more general. As you know, as you probably know, you can have two-dimensional array, not only one-dimensional array. You can have two-dimensional array. So this like matrix. So vector, like in 3 dimensions, positions of a particle x, y, z, is a 3-dimensional array, right? Array of 3 real values. But a matrix, for example, has 2 indices. Like rotating matrix has 2 indices, so it's formally 2-dimensional array. So how we are going to declare and make operations on 2-dimensional array? Well, you can do it. You can do it. So, so again, this is a little bit repetitive process, what I'm saying right now, but that's how it is. So you have to declare the usage of input-output stream as you do in the first line. A standard namespace std. I will describe it in greater detail later. Then you have here the main function int main, empty input argument, the bracket, and it ends up at return 0. Here, this bracket, and then you have declaration of existence of 2-dimensional variables of very fixed size. So it's 2 by 4. So it's a matrix. It's not square matrix. It's rectangular matrix. 2 by 4. So you have together 8 elements. So you have int space name of 2-dimensional variable, and eventually dimensionality can be given, or this can be empty here. So this is declaration. And then step by step, what are you doing over here? You are setting some values to the array. We're setting some values. So it's like 0, 0, 6, of course, integer values. If you put it double, it would be real values. So it will be 6.01, for example. Yeah. So you set the values. So you have 8 positions over here. And then what you want to do, if you start to learn, it's a gradual process. So you have to write a simple program and make it more complicated, and step by step. Nothing is in one revolution step. It is just step by step. So you have 2 loops. So it's loop in the loop. It's a for loop. It's not a while loop, by the way. Just please recognize that. So this is, and because of existence of loop in the loop, it's like nested. One loop is nested in another loop. So of course, here this index is denoted by I, and here's by j. This one is smaller than 2, and this is smaller than 4. But of course, it starts from 0. So and then this is, you should not be afraid of this symbol I++. So instead, I can write the same type effect would be if I write I is equal I plus 1. It would be the same, but people write this in a kind of sexy way. This is double pluses are sexy way in a way. I believe so. Well, so it says that on the next step, such way of writing this must be increased by 1. Yeah, that's syntax. So this is loop in the loop. Basically, you're supposed to have such type of brackets written here and close here and here. But if those 2 loops only are about, so those 2 lines stands for this internal 4, and this internal 4 is executed by another 4. So basically, what is in this line is during execution time, you have streamed on the screen values of arrays. So with all indices aj. So at first you see j values. So for prefixed I, all j are changed, and then if you go to next level, it's simply increased I, and then all runs over all j. So this will be here executed 2 times 4, 8. You should have eight lines. So this is after execution of this double nested for loop. You have C output. C output, this is with one empty line, just for clarification. And then the code is finished. So of course, execution of such code, for sure, it is very short. Nevertheless, let's say if you do the same code in assembler, it will be much faster. So especially in CERN, if there's a passage of a proton every 10 milliseconds, it's coming back. You need to have extremely quick execution of some algorithms, because you get something is checked on the measurement, and you want to adjust the accelerator conditions. So you want to shift. So you have to act in a real time. So sometimes high-level languages sometimes are too slow sometimes. But of course, we are quite lazy, so we prefer to use high-level programming than low-level programming. All right, then you can also run such things. You can predefine these values, two-dimensional values of variable. And you see you have it here. This is alternative, not to write it step by step. It's given like here. You can use such brackets. So you can use such brackets, and yeah. So there are two alternatives to write it. You can see over here. Both are well understandable for compiler. And note that dimensions must always be provided when initializing multidimensional arrays, as is otherwise impossible for the compiler to determine what is the intended element partitioning is. So of course, compiler needs to find the number of memory. And if you want to get a pretty clear existing array that is exceeding the size of computer memory, you will get comment from compiler that you exceeded the memory, that you have to decrease the memory size. So it's very important that I would say you need to understand how things are done with the limitations. You need to understand the limitations of compiler. All right. So you can also. Dobrze. Okay. So let me move on. Now we have another concept, string of char values. So it's as given here. Yeah. So basically it's the same story as it was before, but we have char, hello world, and this is unknown size, and then we give explicit values. I shouldn't come over here. So this is values from the keyboard, letters, right? Char stands for one letter, pretty much. And then we throw out everything on as this output stream. This is hello world. So this is all elements of array, that is string array, are thrown, and then there's empty line and do. And in standard way, there's return 0 for a main function, and it's this. So this program writes hello world on the screen, nothing else. This is done in that way. Right. Okay. now, it's impossible to tell you about everything on C or C++, on C++ especially. There are so many categories of C++ that you might not even imagine how many they are. So I'm giving you a taste. The concept of a teaching is like guidance. It's like philosophical guidance about. I teach you a little bit on the philosophy of things, and then you need to work out individually to be able to. You need to work out individually to simply master the skills. So it's not about telling you all trivial steps. You have very vast literature present. You need to search. You need to use your own intelligence, your own initiative. So I'm kind of a manager of your development, right? So be aware of that. That it's not just elementary school. So somehow at some point, I would expect certain intellectual maturity from you, in a sense that I also highly appreciate initiative, right? So I'm just trying to, just to describe things in a kind of coherent way. Yeah. So basically, this example of usage of already existing C-string library on the slide. So what this is about? So this is input-output stream as well, and then we are using this library, and then we can have standard using namespace std. I will describe this meaning of during next couple of lectures. And then there is main function again, int main, and this return, and sorry, there's this bracket omitted. I suppose closing bracket here. Maybe it's on the end of slide. Yeah. So then, so this slide also exercises array concept. So you have char. So this is like ASCII code, right? So you declare that array will be of ASCII, like from keyboard. This is char of unknown length, but you give exactly the content of this whole array. This is first element, second, third. Yeah, so everything what is inside this char element. Yeah, you need to learn also by doing, by repeating, by copying, and then slightly by modifying. Yeah, and then so you have two different strings in a way achieved by this char. This is another string declaration, and there is third string that is pre-declared that it will exist, but no explicit values are associated with that. So this information needs to be given to a computer program, and to computer compiler, and then then there is a char here again, and this is empty value, as you see. Yeah, so here you have declared 4 arrays that are char, like string array. Finally is one big word or one big sentence stands for each of them. And then you have operations on that string copy. I will give you what does it says. It is about copying one string to another string. String catenation, which means joining 2 strings. So this is about joining some string. I will give you exactly the meaning of string catenation on the next slide, and then finally, the output of this operation is thrown on the screen as a final string. So that's this one. Yeah, and yeah, so we copy one string to another. It's by string copy, I will give you some nice links after this lecture, some nice references, and one of them is based on MIT open course for C++. So you can follow these examples and many other examples as well. Yeah, and this is like so what happens here in string copy is the string fragment 1. So fragment 3 is a copy of fragment 1. So basically fragment 3, which was empty here, is nothing else as the same as string 1. So this happens in this string copy over here. There is string catenation, which is like joining. Joining this, so initially final string was empty string, and this is like joining to empty string with fragment 3. So the output of first operation is of course fragment 3, so final string is like as fragment 3. And then again, there is a joining of another string fragment 2 to an existing string final strings, but this final string was a fragment 3. So in a sense, this is like joining fragment 2 and 3. It's pretty much that's fragment 1 and 2. So that's final output. You need to exercise that. That's quite obvious, and you need to learn how to use libraries and description of procedures present in libraries. So of course you can Google this string and have tons of reading on that, right? Okay, so this was example of usage of some already existing library. I'm still thinking, because I want to a little bit have a small debate with you, but maybe we can also implement some numerical methods in C++. There's like GSL library and so on. We will discuss this afterwards, after this my lecture, so we will have short conversation time. All right. Then, yeah, already shown you how to define this procedure. I already mentioned you about the strings. So, okay, and then this is very highly recommendable www webpage, www.c++.com/reference/. So you have to have tons of examples, which are also included in those slides. So basically, I'm citing that some examples are not by my own origin in a way. I referred to. It's very, from one point of view, such resources given almost for free are a great advanced civilization advantage. But disadvantage is that everything is done almost for nothing or for very cheap price. So you don't fully appreciate this fact. So that's a paradox in this situation. Yeah. But anyway, you have quite instant access to those resources about C++. And then the references, which I promise you to give. So personally, I love those lectures. MIT lectures now on C++ are very kind of compact. I pretty much done probably 2 PDFs of. There's 9 PDFs on this webpage. So pretty much first 2 PDFs on this webpage were kind of presented in the lecture given here. There is definition and philosophy of the flowchart. So the homework for next week would be flowchart for solving quadratic equation and writing a code that solves the quadratic equation. There will be if. So those guys that will do it will have extra points. But anyway, compulsory is flowchart for solving the quadratic equation. Then you have tons of materials, as I mentioned to you. You have Herbert, the complete reference C++. You have tutorials from c++.com. Then you have flowchart programming here. I mean, probably, of course, I omitted many web pages, so it's just very subjective view on the literature. But anyway, I believe those positions are really the first one, and this c++.com is very useful.